Hey guys, welcome to devops school. In this video tutorial, we are going to learn about Docker. It helps us to create, deploy and run applications by using containers. After going through this tutorial, I promise you that the concept and understanding of the Docker will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOps School certification level courses which will help you to emerge skills for a wide range of entry level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai and in Pune. Simply compare our many courses, find the one that suits your style and schedule best and start today.
Now it's getting slower unnecessarily. Not sure what is the reason. So let me cancel it and redo the stuff. Okay, that was good. I'm installing the C version, Community Edition. Okay, so there's something which is missed out. Let me redo the things. This is done. This is done. So it says some error has happened because of some error which is happening.
I think we need to remove that package. I think RPM.
I did so. I did so. Yum install. I corrupted the installer, I guess. Manually I'm doing it. Now it's done. So So almost got installed. Done. Now I'm going to start this, enable this, start this, and finally docker info is the command to validate if it's running. Wonderful. So now I got installed the Docker using this document. Now the question is, what is a Docker or Docker components? What are the components of Docker? So Docker components. So let's discuss about this Docker components. So Docker components has four important elements. One of this Docker engine. Docker engine is the one which is a tool just now I installed it. Now Docker engine is divided into first human, then human send the command to Docker client, okay. Docker client send the command to Docker daemon, okay. Docker daemon send this command to container D, and container D talk to the kernel, and then all this thing happens. The containers get created and managed. Now where is the Docker client? So human is me, which, so what is this? Let me close all this thing. Have to open up one more time console here. Click open, change setting, colors, appearance, section, click OK. Now here we have CentOS sudo -s. Okay. Now
Rajesh,
So, Rajesh, we
screen
are
is
not able to see the screen.
screen. Your screen is a notepad.
how is it? I just unshare and sharing one more time. What you can see now?
It's good now.
Now we can.
Yeah. So here I am going to discuss about Docker engine, the one which I installed is just now. So where is the client? So if you do Docker, you see Docker. Now which daemon? Where's the daemon? ps-ef grep Docker, and see this is the daemon, and this is the container D, which basically talk to the kernel. So this is the first component. Second component is Docker image. Now what is the image? Docker image is nothing but a root file system. Understand that root file system plus user file system. Okay, understand that user file system and plus what? Application file system. In simple way, root file system I have shown you just now. Look at this one more time. Root file system, here it is. This is the root file system. And what is the user file system? User file system means user file system, simple. The file system of user. For example, you want to see my desktop. So I cannot go my desktop. Let me go to C drive. Yeah. So this is my user file system. Okay. So like that, each user will have their file system. Now you want to see the application file system. So typically I install application in C tools. So let's say this is a JMeter application file system. So this is the stuff what you have. So in image, you have a root file system, user file system, and application file system together. Okay. Out of which this is a base image. Okay. And this is a user, and on top of this is the applications. Okay. So this is the image. Now the question is from where we get this image, because remember the image only get mounted at each container root file system. See here. Okay, whatever you have in image you have inside a container. Okay, so this is the things. Now here important thing is from where to download the images, because I'm not going to create image right now, I'm going to use it. So here you're going to download the images from the Docker registry. Okay, there's a two kind of registry, public registry, okay, and private registry. Private registry means you can only see that, for example, Artifactory, Nexus, and stuff like that. Okay, these are the private registry, ECR on AWS. But public registry means what? What are the public registry? So public registry means hub.docker.com. Hub.docker.com is a public registry. Anyone can access it. One of this Google registry. Anyone can register it. So here for this, if I look at this hub.docker.com, which is the default registry for Docker. Look at this here. Go to hub.docker.com. and log out. See here, read this, how many images you have. So many images, more than lakh images are there. So now what images you want? So you have to decide MySQL, Jenkins, Ubuntu, Fedora, Debian, MySQL, this, that, whatever image you want, you can download from here. Okay, it's a public registry. Anyone can write, anyone can read. Okay, so this is the registry. Now last component what we have in a Docker ecosystem, and that is called Docker container. So what happens? Simple. What is a Docker container? I have already said, I have already told you what is Docker container, but here I'll tell you. The moment, understand that the moment you run image, okay, one user namespace get initiated with image with one process map PID and one network and mounted from the image. Yeah, from the image itself. This is what it happens. What username is get initiated with one PID, one net, and mounted from the image only. So the whatever the image you have, you see inside the container. Understand that? So from the one image, you can create as many. From one image, you can create as many containers you want it. Okay, so this is the Docker components. Are you comfortable with this so far, guys? Are you comfortable with this?
So one Docker image belongs to one container. Huh?
No. Docker image consists of root file system, which is this one, user file system plus application file system. The moment you run image, you get container. Simple way for you. You run image, you get a container. So here you get container because one user namespace got initiated with a one PID, one network, and mounted from the image. This is what I was talking about here also, right? What is a container? So container is same thing. User namespace with their own mount, PID, network, powered by Docker, and Docker is taken from the kernel. Understood that, guys? This is a Docker components. Any questions? Any questions, guys?
So like one Docker image, we can create many containers. So
yes.
Can you example this one?
I'll show you the demo in 5 minutes.
Okay, fine. That's fine.
Okay, now next thing is now Docker components. After that, Docker workflow. Okay, so what is a Docker workflow? So see here, understand that. First thing, what happens? Let me show you the tutorial. This is your machine. Okay, this is your machine, and this is the client, and this is the daemon. Okay, so this is the daemon. So human write and send the command to client, which I told you here also. See here. Okay, client will send the command to daemon, and daemon will check this run what some image, let's say Jenkins. Okay, so Jenkins image you want to run. So this Docker daemon will check, do I have that image in the local registry, LR, local registry? If there is no, then they will go to dockerhub.com, download, keep it from here, and then container got created. Understand? So Docker daemon will check in the local registry. Now where is the local registry? Let me show you. Docker info, if you do, see here, registry. This is the hub.docker.com and local root Docker root directory. This is the registry at one place. Okay, so inside this directory, images will be stored. Okay, so how many images you have? Docker images. See here, there's no images. So what we do? We'll go to hub.docker.com and download, search some images. Jenkins. Jenkins is one of the popular CI tool which we are using. So Jenkins. And here you see we search that Jenkins. Now here you see there's so many results has come, but you can decide, depends on the number of download, number of rating, number of stars, official image, and so many filters are also given. You can check it out. Click on this. And I'm going to pull this image. So if you want to pull this an image, you want to Docker pull Jenkins. I'm pulling this image. Okay, so guys, I pull this image. Now can I check that images are there or not? Yes, this is the image. Jenkins latest image ID 2 years ago site. So this image I got it. Now what do we do in this case? So this is the workflow. Understand that Docker workflow. First human will send to the client, client will send to the daemon, daemon will check, would check if image is in LR local registry, if local registry is there, if yes, create a container, if no, download from hub and copy into local and then create a container. Guys, did you understand this? Everyone? Hello?
Just Rajesh, what is the daemon?
Daemon is the one which I said, right? Here, Docker daemon. Okay,
Kind of hot.
Yes, I can hear. Docker. It's application which is running with daemon. This only talk to the containerd, and containerd interact with the kernel to create a container, because see this. So this the whole thing together, we call it Docker engine. Except the kernel. Got it? Yeah. Okay, guys, can we move on?
So now you are downloaded Jenkins image, correct? That is installed in this system. In this, it's already installed.
Not installed. I downloaded.
Okay,
so
okay.
Here I got it. I downloaded. That's all. I did not install it. There's no installation.
Fine. Got it.
Docker I installed. So I got this image. Now guys, last one is container workflow. So what is container workflow? So guys, it's like a VM only. In the VM, you create a VM, then what you do? Start the VM, then you stop the VM, then again you start the VM, and again you restart the VM, again you pause the VM, again you unpause the VM, again you kill the VM, and again you remove the VM. So this is the same workflow we have in a container also. Can I do that in front of you? Let's do that. So here, Docker, clear the screen. Let me show you. Docker ps. Docker ps will tell me running container. Docker ps -a will tell me running plus exiting container. A means all. So now, can I create one container from the image which is called Jenkins? Docker create, and here you see it's not running. -a, it's got created. This is the container ID. This is the name of the images. This inside the container. It should be running and created 4 seconds ago. It's got created. Now, can I start the container? See here, I started the container. Now you see, it's up, it's running. Can I stop the container? Can I stop the container? So here, stop the container, and here, this is the, see, exited. So whenever you see exited, that means at least the container has run at least one time. So I stop the container. Can I restart the container one more time? You see here, I restart the container. You see, once again is up. Can I restart the container? See here, I restart the container, and here you see up once again one more time. Earlier it was few seconds by the time I restarted. Now can I pause the container? So see here, I pause the container. Pause PAU, pause the container. You see here, pause the container, and it's got paused. You see, paused. It's mentioned here, paused. What is a pause means? Pause means container do not get CPU. See here, CPU 0%. So can I unpause the container? Can I unpause the container? And you see here, container will start getting the CPU. See here, started getting CPU. So finally, can I kill the container? Kill means brutal killing, like forcefully stopping. If stop is not working, then you can use the kill. Okay. So kill is a brutal way to kill the process. Kill. I kill this, and you see here, container got exited one more time. And finally, can I remove the container? So RM. So see here, this is called container life cycle, and so easily we could cover all this command in one go. Did you understand this, guys? Workflow? Did you understand this?
Yeah. So why the container name is like unique name?
This is the 40 character unique name, you'll get it, and first few characters will be displayed as because of uh, uniqueness and to ease to read it and also like that.
So we can't mention like application name, some other names like that.
Yeah, one is ID, one is a name. You can mention name also, you can mention ID also, no problem. So here if you see here, there's a name also given, randomly generated name, Docker PSC here, PS-A. See here, oh, there's no container, no, I deleted, right? So I have to create. So create and start. Create and start the container. Okay, you see here, you got this name here, unique name. This is given by Docker. You can rename it if you want, don't like that name. And ID is also. Okay. Okay, guys. Now there is a one command which is very popular and people use it all the time, and that is called run. So what is the run meaning of it? So let me talk about run now. So run means what? Run means create. It will do the pull also, by the way, and then create, then start, and then become. Okay, this is the fourth thing you will have in run. So what is a become means? Become means right now you are a shell. Right now you are a bash shell. Okay, echo dollar echo dollar shell. So right now, sorry, spelling mistake, ECHO. Okay, see, you're a bash shell right now, but at that time you will become that container. Your console will become container if you use the run. So for example, docker run. and here I run Jenkins. So what it'll do, it will create one container, new container, it will start the container, and you will become, you see here I lost the console, I become Jenkins container. See here, so container, I lost the container, I mean sorry, shell. So now I'm become that guy, I become Jenkins, I become a Ventini, whatever it is, whatever the Jenkins, whatever the container is running with, I will become that one. So now what to do, I have to kill this, control C, I kill this, now this container got killed. Okay, so remember, so if you want to do run, you become, if you don't want to become, then use -d, that's called detach mode. So here do not become, so in that case, now if I do, look at this here, docker ps, there's one container running, docker run -d Jenkins, and you see I did not become, still I am a shell only, and you got another containers which is running. So did you understand the run command, and with a d, without a d, guys? This is called detach mode. Did you understand this, guys?
So like, can you show the example how you become, how do not become that
Simple,
prompt?
no? Run will become, I just now I showed you this. You run, you become Jenkins. This is you, Jenkins. But if you do control C, I just clear the screen, and you see with -d, you do not become, that detach will not happen. Simple. You are a shell.
The, run Docker run Jenkins also same shell, correct?
What is that?
No. What I'm trying to say, when you run first command, also your still remains on same shell, correct? Shell is not
No, no,
changing.
no. Changing, no? See, I lost it here one more time. See, where is a shell? It's a log of bint in it. Jenkins log. Where is the shell? I lost the shell forever.
Okay,
Got it?
so forever you lost here. Okay, fine, got it.
Yes, we lost it. Yeah. So then I pressed Control C, and then I got back.
Okay,
I killed that containers. Got it?
yeah.
This is called detach mode. Attached. This is called detached. Okay. Clear, guys? So far, any questions? Govinda, any question?
No,
Jake,
Rajesh.
LA, LA.
No, I'm good. I'm good. I'm good. I attended the class for yesterday. I was talking on mute.
Okay. Mohammed,
Hello, yes, I
MRU,
got it. Yeah, I got it.
Yeah, looks good. Yep, I
Murli,
got the concept. Thanks.
Good, no issues.
Murli,
Yeah, I'm good, no
and
issues.
Naresh. Okay,
Looks good
guys. So
so
let's
far,
move
so
on
good.
now. Yeah. So now let's talk about the rules of PID1. You need to know rules of PID1. Understand that, guys. Very simple concept. I don't know whether you noticed or not. PID1. Let me show you. So here you run application in physical machine, and you run an application in virtual machines, right? Virtual machines, and you run application in the container. So what is happening here? Okay, in container, physical machine is running as long as PID1 is running. Understand that. Simple. Physical machine is running as long as PID1 is running. Virtual machine is running as long as PID1 is running. Okay, understand that. This is hard coded. Let me show you the virtual machine. This is my virtual machines. This is my virtual machines which I created on AWS. So now I want to show you the what is a PID1. See here. This is the PID1. If you shut down this computer, system D will be get detached and system will got shut down. So your system is running because of this is running in daemon mode. Because of this, PID1 is running. PID1 is running because of all these are running. So because of PID1. So here guys, same concept we have in a container also. A container is running as long as PID1 is running. See here, PID1 is running. This is clear. Now you see here, Docker PS. Right now, this is the PID1 Bintini, Bintini, Bintini. This is running because of that. This container is running. This you killed it, container will get killed it. Remember, many times I I ran it and I killed it. Control C and Bintini got killed, container got exited also. Those containers you can see here. See here, exit, 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 exit. All these are exited container because I killed it PID1. Now, so this concept, understand this. Now in physical machine, PID1 is system D. Okay. In virtual machine, PID1 is system D, which I showed you just now. In container, PID1 can be anything. That's a difference, because see here, what is the PID1 of this container? Do you want to see that? See here, this is the container. Clear the screen. This is the container, and here Docker exec container ID and ps-af. See here, what is the PID1 inside a container? I'm executing this container and trying to find out the process table. What is the PID1? Bintini. But what is the process of PID1 in my VMs? Look at this, ps-ef PID1 system D. So here that's the only difference. Understand, that's very important. So please remember this statement. Physical machine is running as long as PID1 is running. Virtual machine is running as long as PID1 is running. Container is running as long as PID1 is running. PID1 is not running. Container, physical machine, virtual machine is not running. It got shut down. Now PID1 in the physical machine is a system D. PID1 is in a virtual machine is a system D, but in a container, PID1 can be anything. And now who keeps the PID1? The moment you create images, you can declare the PID1, and that you can do that. So with that notes, I'm going to talk about how to consume containers, because you have used so far all this workflow. So you created lots of container, but how do you consume a container? So first thing, how to go inside a container. See, when you create a machine, you either log in or you access from outside. That's the two thing you can do that, right? Log in and do something, or come out of and then access from the outside some application which is running in your machine. So how to go inside a container? So there is a two ways, exec way and attach way. Okay, now question is, what is exec way? So exec way will would execute execute an executable, okay, inside a container. Understand that, inside a container. So can I show you first? Let me show you here. Control P, Docker PS. These are the container running. This is one of the container. Can I exec? Docker exec. Inside which container? What? LS. What? df-kh. What? Anything you can run.
So we are
anything.
not able to see your screen.
You are not able to see?
Now we are able to see. Now we are able to see.
Yeah. Okay.
Gap
So
is
Docker
there.
exec ls. Okay. Docker exec and container ID and ls. So here during exec commands, you can run any executable inside a container if it is exist. Would execute an executable inside a container. So see here, you can run any commands, dff-kh. Look at this. Got it, guys? But the question was not to execute.
This
The question.
So sorry to interrupt. df-kh, you are executing the command for this particular container, correct?
Inside this container, yes, inside a container.
So
see, Docker
just now
execute inside container.
Okay, I got it. So can you execute again only df-h kh? No, only df-kh.
In the system, you will run this.
Yes, correct. Just I wanted to see the difference. Okay.
It's a system. No?
Yeah. That is container. This is system.
Yeah. Any with the Docker is a container. Okay.
Oh, okay, got it.
So how the question was how to go inside a container. So basically, you can use with exec with -it with exec and bin bash bin bash means shell. Okay, bin bash to go inside a container, okay. So this is the one. So can I do that inside a container? Look at this here, docker ps. This is the container I am on to go. So docker exec, okay, docker exec -it container id and bin bash. See here, I'm inside a container. You are inside a container. See, I'm inside a container. This was outside of the container. And exit. So yes. So exit, and this is the command I run. Okay. Sorry. Sudo -s. Okay. So this is the command I run in order to understand all the stuff. So
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devops.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.